Okay, so we're going to kind of compare and contrast the traditional method of hypothesis testing and the p-value method of hypothesis testing, and talk about what the key things are in each step. So you can see in both methods, the traditional method and the p-value method, the first step is to state the hypotheses and identify the claim. So when you do that, when you state the hypotheses, Amanda, what are some key things you have to remember?
You have to figure out which is the null and which is not.
Okay, and the null, we'll always use this symbol for null, right? Okay, so H6.
And then the null, you always have the equal bar.
Okay, so I was going to have, in the first, I'm either going to have equal, greater than or equal to, or less than or equal to in the null, correct?
Mm-hmm.
Okay. Tyler, anything else that you have to kind of remember when you do that first step?
You have to make the claim.
You have to say which one's the claim.
Mhm.
Is it correct? Okay. So, for example, let's say that we say less than or equal to 0.82. Then this symbol would be greater than 0.82. What symbol am I always going to use here? Or can it be different symbols?
Different.
Can be different, right? If I'm using a proportion, what symbol would I use here? P. What if I'm making a hypothesis about a mean? You use mu, yep. And what if you're making hypothesis about a standard deviation? Sigma, yep. Lowercase sigma looks like that. How about if you're making a hypothesis about a variation or variance? Yeah, that's sigma squared. So you notice they're population parameter symbols. They're symbols that are trying to make a prediction about a population. Okay, generally they're Greek letters, other than the proportions as it looks like RP. So let's say we're making hypotheses. If it's singular, it's hypothesis. If there's more than one, it's hypotheses about a proportion. So let's say we're going to use P here. So you got to make sure you use the right symbol there. Step B, find the critical values. So if you're doing hypothesis testing, you find the critical values. So to find the critical values, you have to think about where would I get those from. Bria, do you know where you get the critical values from?
A chart.
A chart. So it's either some type of table or chart. It's either a z-table or a chi-squared table or chart or a t-chart. We're going to look at f-charts in this next chapter, chapter 9. So it's always going to come up with a chart. All right. How about thinking about how do you know whether you're going to have one critical value or two critical values? Liz, how do you know that?
If it's equal, then you have two. You have positive and negative test values. But if it's just on one tail, you have just one.
That's right. Well, you guys sound like you know what you're doing. All right, that's good. Yes, if that's an equal, not equal, it's two-tailed, you'll have two critical values. One on the right tail, one on the left tail. In this case, if P is greater than 0.82, and the claim could go in either place. Let's say I put the claim down here. That means it's going to be right tail, because the alternative that it's greater than, the proportion is greater than 0.82. So in this particular example, I would only have a right critical value. Okay? So my critical value would be over here in this example. And I'm drawing, this would look like the standard normal curve, which is the z distribution or t distribution. The chi-square distribution is not symmetric. It's skewed right. So if it's right-tailed or left-tailed, one critical value. If it's two-tailed, two critical values. Oh, let's go over here. Look at step B over here. Compute the test value. Look at step C over here. Compute the test value. So step C in traditional method is the same as step B over here. Notice we did not have to find critical values when we did the p-value method. Okay? When you find the test value, what are you going to use to always find the test value? Leslie.
Z, T, or the chi-squared.
Is it going to be a chart or a formula?
Formula.
Formula. You can use some type of formula. Okay, unless you use the built-in functions on the calculator that figure it out for you. But you're going to use some type of formula. Okay? It's either z, t, or chi-squared. Depending if you're doing a proportion or a mean, the z formula can change. But you're going to use some type of formula here. So you're going to use a formula. Here you're going to use a chart. So up here you start with a formula if you're doing the p-value method. Okay? And you're going to find zt or chi-squared, or in this chapter we're even going to learn how to find an f test value. Part D. reject or not reject. So when you're doing the traditional method, let's say you're doing the traditional method, you're trying to do step D, and you've got some type of test value here, and you've got some type of critical value here. How are you going to tell whether reject or not reject when you're doing the traditional method? Christy.
If it's outside, like the critical value,
Okay, so if the test value
reject.
is outside of the critical value, it's in the rejection region, you'd reject, right, okay? If the test value falls in the critical region, in this case it's the right tail, you would reject. If the test value falls here, you would not reject, okay? And then step E, well, let's go over here, let's finish this over here. Step C, find the p-value, okay? So let's say you've got your some type of distribution. You didn't have to find the critical value here. Instead, you find the test value. Let's say the test value is here. What part of this picture is considered the p-value? What part of the picture is the p-value? Pick on some people. Let's see, Nicole. The shaded tail. Yep. The area outside of the test value is your p-value. So that area right there is the p-value. The area outside the critical value is alpha. Okay, so two different names for those two areas. So when you're finding the p-value, when you look it up on the chart, when you go to your chart, say you go to a z-chart or a t-chart, and you look up an area, does it give you that area right away when you look at your chart? No, it doesn't, does it? It gives you this area right in here. Like your Z chart will give you this area. So then what do you have to do to end up getting this area, your p-value? Subtract from 0.5. Yep. What if it's two-tailed? What if it's a two-tailed test? You got to double that number. Yep. Whatever this number is, you got to double it. The p-value includes both of those. Okay. So here on step D, if we're going to if the test value is in the critical region, you reject. Reject the null. That's not how you decide over here. Step D in the p-value method, how do you know when to reject?
If p-value is bigger,
Is less than alpha.
Right. If the p-value is less than alpha, then you reject the null. Because if the p-value is bigger than alpha, or p-value is less than alpha, let's say my critical value, let's say, is right here. Say that's my critical value. This is my alpha right here. Alpha's in blue. Okay? So if the p-value is smaller than alpha, that tells me the test value must be in the critical region, so I reject the null. Last step, E, to summarize. When you summarize, if the claim is in the null hypothesis, what's the key word you're going to use in part E?
reject.
Right. You're either going to say, if the claim is up here, so if we reject the null, then we would also we would say there is enough evidence to reject the claim. If we don't reject the null, we'd say there's not enough evidence to reject the claim. Okay? So when the claim is up here, use the word reject in step E. And you always talk about the claim in step E. If the claim is down here, then what's the key word you always use in step E?
Support.
Support. You're either there is enough evidence to support the claim, or there's not enough evidence to support the claim. So, for example, if we reject the null, that means we think it's false. That means we think the claim would be true. So we'd say there is enough evidence to support the claim. If we don't reject the null, then we think the null is true, which means we think the alternative is not true. We'd say there's not enough evidence to support the claim. So if the claim's in the alternative hypothesis, you either say there's enough evidence to support or there's not enough evidence to support. Any questions or anything else to add to that? Let's stay running the whole time. Good.